Okay, so the assignment that we have to apply TSNE goes as follows. Again, this is the same sheet, right? This is the same IPython notebook where we performed basic loading of data, data analysis, the univariate analysis, featureization, building the data matrix, all of that. We are trying to put this in the same sheet so that things will flow for you. Things will be easier for you, right? And you have code to start working with. Instead of working from scratch, you have already pre-existing code to work with. So for this assignment, right, very, very important stuff is if you are using any code snippet from the internet, you have to provide a reference or a citation, just the way we did in the above cells. Please do that. Otherwise, we will treat it as plagiarism without citation, right? Please, this is a very, very important habit that we should all inculcate. Okay, I cannot emphasize this enough. Please, I request all of you. We will not penalize you, right? It is just as a good programming habit. We also know where you have taken the code from, right? And if you can tell us what Google search results gave you, that's even better, right? But minimum of minimum, if you're using any code snippet from the internet, please tell us the reference or citation. And we respect the fact that you're doing it. If you don't do it, and if you discover, which is fairly straightforward for us, if you discover that you're not writing the citation, but you're just copy pasting it, we will treat it as plagiarism without citation, which will have consequences. Okay. Having said that at the outset, right? So this is what this assignment is. And before I go into the assignment itself, I want to give you the methodology, that we have followed to design each of our assignments, right? We have designed each of our assignments to be very close to a real world. Okay, we have designed each of our assignments to be extremely close to how you would actually perform analysis in the real world. Okay, and all of our analysis will be very thorough, because once you learn as part of our course how to do thorough and exhaustive analysis, this will teach you on how to be a good data scientist. Once you join a company as a data scientist or a machine learning engineer, this is what your manager would expect. And if you do all of this, the manager will be super happy, because this is what a thorough, exhaustive analysis looks like. And when I was a manager myself, when I was mentoring people or when I was managing people, we had to teach this to some young freshers, especially fresh data scientists. We had to teach this over months to tell them how to do exhaustive and thorough analysis. The advantage you have is on day zero, as soon as you join a job, you will be able to do very good, high quality and thorough analysis, right? Because you've learned that as part of the course. And we take it very seriously that we want to teach you to be not just a data scientist, but a good one, because that will help you grow in your career. Our job is not just about teaching you some techniques and say, okay, you go figure out the rest. No, our job is to handhold you, to help you become a good and successful data scientist, right? That's why most of this analysis is going to be very thorough, and we will not take shortcuts in this, please. Okay, so the first task is, in all the above cells where we have plots or where we have analyzed many features, please observe the plots. I've already explained this in the previous videos. Please write down the observations like a summary. You can just say summary. Okay, for each of the plots. I've already explained it in the videos. We didn't write it ourselves. I think we wrote only one summary in one of the previous videos in the cells above, because we want you to write what you understood from each of these plots, because that is more important. Just plotting is not important. The more important thing is, what did you learn from these plots, right? Because that's what matters when you explain your data or when you explain your univariate analysis to someone. What matters is not just the plots, but what have you understood? What is the key takeaway from these plots or analyses, right? So for each of the plots that we have, please write down what are your observations. What did you learn by going through our videos and by looking at the plots yourself? That's task 1, right? Tasks 2. So we have left some exploratory data analysis, right? Like for example, we have left some exploratory data analysis of teacher number of previously posted projects. Please finish that, right? That's number 2. The third thing is, let's build the data matrix now. Okay. We have a bunch of categorical features. We have school state as a categorical feature, which you can one-hot encode. We have clean categories, okay, which is again categorical data. But given a project, you can have multiple, let's assume these are all of our categories. clean categories, category 1, category 2, category 3, category 4, category 5. Given a project, it can belong to category 1 and also category 3, right? So this will be also binary encoding, but multiple categories can be set to 1. Okay, this is for clean categories. Similarly, clean subcategories. Again, we have some of this code already explained for you on how to do one-hot encoding, all of that stuff. You just have to build a data matrix using these columns, right? So you have school state as a categorical variable. You also have clean categories as a categorical binary variable. Similarly, clean subcategories. You have teacher prefix, which is a categorical variable. Your project title, let's use the project title itself, not the project essays, just the project title. Let's encode it using bag of words, TF-IDF, average word to vec, and TF-IDF word to vec. There are 4 possibilities here, right? And so you have a bunch of categorical features here. All these are categorical features. This is basically your text, right? And you have 2 numerical features. Okay, the 2 numerical features are the price and the number of previously posted projects by the teacher. So we have a bunch of categorical features. We have 4 possible encodings of a text only in the title, not in the essays. Let's just use that. Okay, and the reason we are doing some of this is because some of our students may not have very powerful computers, right? So we don't want them to wait for days to finish a project. Okay, just for the compute to get over. That's why we are simplifying some of this, right? Okay, so given that you have built a data matrix like this, we want you to work on 4 TSNE plots. The first TSNE plot, 4A, will have the categorical features, all the categorical features, all the numerical features, and the project title encoded as bag of words. This is your feature set. On this feature set, please use the TSNE plot, right? Let's use TSNE on this. That's first. Okay, the second one is, this is the first TSNE plot that we want to see. The second TSNE plot is, let's use the categorical numerical features, but for project title, instead of using bag of words, let's use TF-IDF. This is your second TSNE plot. The third and fourth TSNE plots, very similar. You use categorical and numerical features, but instead of using TF-IDF, you use average word to vec and TF-IDF weighted word to vec. Okay, so these are 4 TSNE plots that you'll show us. Again, you might wonder, why do we need to do all 4? Because you want to understand which featureizations are able to separate those projects which are approved and which are not approved, right? So these are 4 TSNE plots. The 5th TSNE plot that we want you is concatenate all the features. Have all the categorical features, all the numerical features, and all of these project features. The bag of words, TF-IDF, average word to vec, and TF-IDF word to vec. Apply TSNE on top of the final data matrix. So in total, we'll have 5 TSNE plots. This will help you understand and see different types of TSNE plots. And under each plot, please write a summary of what you learned. Okay, the objective here is for you to do a thorough analysis. Imagine if this was a project given to you by your manager in an actual real world data science team. If you perform all of this analysis and take it back, the manager and your peers will be super impressed that you have done a thorough analysis without taking any shortcuts, right? The other very important thing here is the TSNE that we have in scikit-learn, okay, only takes dense matrices. Okay, so you'll have to learn how to convert some of these sparse matrices to dense matrices, number 1. Number 2, please don't use all the data. Don't use the data for the 109K projects because most of your systems do not have the computational resources to do it. What we are suggesting here is just randomly pick 5,000 to 6,000 data points to avoid, because you don't want to go into memory issues and out of memory errors and stuff, right? If you pick 5 to 6,000 points, if you have even 4 GB of RAM on your laptop or desktop, you can comfortably finish this, right? If you do not even have 4 GB of RAM, let's say you have 2 GB or 3 GB of RAM, it's perfectly okay for you to run it on fewer than 5 to 6,000 points. But clearly state the number of projects that the number of data points or the number of projects that you're using, so that we know that you have some memory issues because of which you used it. Okay, it's okay. Some of this might take a couple of hours to run, but please be patient. Because in the real world, when you run some of these complex models, it will take time and you have to get used to that fact. Okay, sounds good. Now, in addition to this, we also broken up these sections, right? So in this section, so this is the code. You can actually write your code here. Here you have to write TSNE with bag of word encoding for project title. TSNE with TF-IDF encoding for project title with all the categorical and numerical features. So we have also given you these logical blocks. Okay, while we have explained the whole project itself or the assignment itself, this is not a project. A project contains many pieces of many pieces of analysis like this. This is just one module in an overall project, as you'll see in some of our case studies, right? Okay, so we've given you these logical blocks and also a simple block called summary, where you can write your overall observations about this data set when you apply TSNE. What did you learn from it, right? And again, we want all of you to succeed in this, because at the end of the day, we will help you through this process. Okay, any question, any query that you have, please shoot an email to us. We will respond back in under 24 hours to the best of our ability, right? That being said, also put in the effort. Try to Google search, because because at the end of the day, you will have to learn, right? At the end of the day, you'll have to learn. Once you join a team as a machine learning engineer, you can't keep asking people for help, right? You'll have to learn to Google search and figure out things for yourself. So please spend some time on these assignments. And the reason we designed our assignments is because we want to build good data scientists and machine learning engineers. That's our goal. Our goal is not to produce some tier 2 or tier 3 data scientists. Our job is that we want you to be some of the very good data scientists and machine learning engineers in the industry.